Hi there. Thanks for tuning into this video presentation about our CHI case study titled Informing Housing Policy Through Web Automation, Lessons for Designing Programming Tools for Domain Experts. The context for this case study is that housing has reached historic levels of unaffordability across the United States over the past couple of decades. Moreover, there are important inequalities by race, ethnicity, and socioeconomic status in terms of how burdensome these rising houses have become for different families. However, to be able to adequately study housing problems like unaffordability, social scientists need timely and spatially granular data about the conditions that households face when they're searching the market for their next dwelling. While existing public and industry data come with important trade-offs in terms of their timeliness, geographic specificity, and methodological transparency, data about housing opportunities in a given area are nonetheless publicly available 24/7 on websites like Craigslist and Zillow. The chief constraint is that social scientists do not typically have training in web languages like HTML and JavaScript that can be essential to creating web automation scripts by oneself. Instead of this being a persistent constraint, this training gap presents an opportunity for folks in the computer science community to work with social scientists to create tools that meet the needs of social science users who have domain expertise but may lack particular technical skills for a task like web automation. With that context in mind, our case study is a multi-year collaboration between researchers in the social sciences and computer science based on using a novel web automation tool called Helena to collect housing advertisement data. Using Helena has enabled a team of social scientists from a variety of disciplinary perspectives to work together on computational social science research focused on housing inequalities and housing policy in the United States. Throughout the rest of this video presentation, I'll introduce the Helena web automation tool, I'll discuss the design guidelines we contribute to our case study, and I'll briefly summarize the 3 phases of this project's growth over time. I'll now briefly introduce the web automation tool Helena that is at the center of this social science computer science collaboration. Helena is a programming by demonstration tool for writing web automation scripts that users interact with via a Chrome browser extension. And in the screenshot on the right, you can see what this looks like in practice, with the Helena Chrome extension on the left-hand side triggered to collect data from Seattle's Craigslist page for apartment listings on the right-hand side. And within the extension window, Helena shows the fields that the user has selected as the first row of the data set that they would like to collect in the future. Importantly, Helena allows users to demonstrate scripts for data that is distributed across a number of web pages, as is commonly the case with listing data on sites like Craigslist. So carrying the example from the prior slide forward, on the right, we can see that the user has demonstrated that additional fields from each individual ad be collected as part of the Craigslist scraper being programmed. Finally, once a demonstration is complete, Helena synthesizes the demonstration into a script that can be edited within the same browser extension that users demonstrate their data of interest with. This is important because it gives users the capacity to tweak a script that may be close but not quite right. The script editor also allows users to program how the scraper handles navigation through multiple pages or how it handles the scraping of duplicate data, among other things. Since our design guidelines are a key contribution of our case study, I'll now briefly review them before sharing some of the project experiences relevant to how we arrived at them. The first of our design guidelines is to design for easy first drafts. And specifically, this means prioritizing easy prototyping and enabling users to create a functional proof of concept quickly. To the extent possible, this also means letting users draft working programs first, even if they don't understand the technical complexity, and even if they will eventually benefit from understanding this technical complexity. The second guideline is to design for scaling up computation. In other words, first drafts should be able to be extended or productionized into large-scale or long-running projects should user goals eventually require this. The third guideline is to design for scaling down human effort as project complexity grows. And this describes how human interaction burdens that are bearable during the prototyping stage may become overwhelming as a project grows in its scale. And as a result, it is useful to design applications such that small amounts of additional programming effort can be substituted for large amounts of other human effort. The fourth guideline is to design for integration with other tools. This means to prioritize the ability to import, export, and transition inputs between the tools that are already prominent in domain experts' technical skill set. Finally, our fifth guideline is to design for single users who have mixed expertise levels. In practice, this means to make manual and programmatic manipulation available so users can switch freely between them at any point in a project's lifecycle. This is important because even as users develop technical skills, they continue to face fresh challenges that sometimes they may be able to tackle most efficiently via the interfaces designed for non-technical users. I'll now give some examples from our paper about how we arrived at these 5 design guidelines. During the pilot stage of our project, the fact that we were able to get started with scraping based on just demonstrating the data of interest was integral to freeing up time for us to think about how we would process and analyze the data for our report. This experience informed our guideline about facilitating easy first drafts because project success at this stage hinged on being able to prepare a sample of data and analyses within a relatively short period of time. Further, the fact that Helena exported CSV files meant that there was essentially no friction for being able to incorporate that within our existing workflows. The second point informed our design guide about prioritizing integration with other tools, since many social science users have existing technical skills in data analysis software like R that can be complemented with tools like Helena. After our proof of concept stage, we sought to expand our scraping to cover all Craigslist pages for the largest metropolitan areas in the United States. Crucial to our success at this stage was that we could deploy the Helena scripts demonstrated on our laptops onto virtual machines where headless Docker containers ran Helena scrapers. This experience is part of what informed our guideline related to scaling up computation, which describes tools being designed such that the first drafts can be extended to handle larger workloads to the extent that this becomes a project priority. The third and final stage of our project has expanded our data collection based on Helena to cover multiple housing platforms at a national scale. Updates to the Helena tool that were informed by our project have meant that we can now demonstrate a single Helena script for a source, parameterize the starting URL, and then deploy the scrapers for all locations of interest. This motivates our guideline related to scaling down human effort, since a small amount of additional programming capacity yielded a large return in terms of the time required to create scrapers for a given source. And while we were building out our expanded system, we did notice an unexpected case where Zillow containers never reached a completed status. And running the relevant scraper program outside of our virtual machines in the Helena GUI let us watch what was causing our programs to stall, at which point it became clear that ads for content other than vacancies were failing to load. This informed our guideline about designing for users with mixed expertise levels, while also providing another example of how Helena's easy integration with other tools helped us overcome new obstacles encountered while growing our project. Overall, our case study illustrates how new computing tools can be an integral part of collaborations between folks in computer science and different social science disciplines. For social scientists, collaborations like the present project are an invaluable source of new opportunities to study social phenomena like this housing search process. And for the CS community, this case study highlights design guidelines that enable applications ranging from one-off uses to ongoing projects with multiple stakeholders. And with that, I just want to thank you for watching our video presentation. I encourage you to check out the full paper if you're interested in learning more about what we've done.